Welcome. Today, we're embarking on an exciting journey to understand SQL, the language of databases. Let's dive in. SQL, originating at IBM in the 1970s, functions as our magic spellbook for managing data in databases. It allows us to read, add, change, and remove data using commands like select, insert, update, and delete. It has evolved into a standard tool for data interaction, pivotal to both database navigation and data integrity. The image on the right represents our journey into the realm of SQL, indicating the key commands we will master. In this course, we set out to build our fluency in SQL, understanding how to navigate and manipulate databases like seasoned magicians. A database is typically a central repository designed for efficient data management, encompassing components such as tables, fields, and records. Picture a database as a library, where tables are books, fields represent different topics within a book, and records symbolize detailed information under a particular topic. The main purpose of a database is to ensure data can be stored, organized, and retrieved efficiently. SQL, or structured query language, is akin to our guidebook, enabling us to navigate and manipulate data within our database library. SQL offers commands such as select for data retrieval, join to unite data from multiple tables, insert to add new data, update to modify existing data, and delete to remove data. We'll delve deeper into these commands in our upcoming slides. SQL syntax, our database spellbook, offers commands that tell captivating data tales. Imagine crafting your kingdom with create table Elvenlands, resource varchar, treasure int, epoch date, and populating mythical creatures with insert, update, or delete. Just as we need a varied cast for our tales, we work with different data types and constraints for an efficient database. Data types, int, varchar, date, specify what can inhabit each column, while constraints like primary key, foreign key, not null ensure every data actor plays its part perfectly. For instance, create table heroes guild, hero ID int primary key, hero name varchar 100, not null, join date date, forms our hero guild with right precision, thus shaping our SQL narrative. The select statement serves as the key to unlocking the data within our databases. The syntax couldn't be simpler. Select column name from table name. Now, adding a where clause refines our query with a precision filter. This enables us to retrieve data that meet exact conditions, creating an even more effective data search tool. For instance, if we want to find heroes with a specific weapon in our database, our command should read something like this. Select throw from heroes, where artifact equals crystal sword. By using both select and where, we can now fetch any specific data we need for efficient and focused database manipulation. A where clause in SQL allows us to filter data based on specific conditions. It is formatted like this. Select columns from table where condition. It lets us zero in on the data we need. For example, to find all heroes who belong to the Ranger class, the query would be select name from heroes where class equals Ranger. This displays how the where clause allows us to precisely extract data. Moving on to aggregate functions, these are critical tools used to generate insights from our data. They include count, sum, avg, min, and max, each serving a unique purpose. By using the where clause with aggregate functions, we can extract specific insights from our data. For example, to understand the total strength of our Ranger class heroes, we might use the command select sum strength from heroes where class equals Ranger. Using these two together supercharges our data retrieval capabilities, paving the way for effective data analysis. Join operations in SQL link tables based on related columns. Precisely, the syntax goes like this. We select the columns from the first table, join it with the second table, and then specify the common columns in both tables using the on clause. There are 4 types of joins: inner, left, right, and full, each serving a unique purpose. Let's break them down. An inner join matches only the rows in both tables where the condition is met. Using a left join, we get all rows from the first table and only the matching ones from the second. With a full join, all rows from both tables are selected, matching rows where possible. For example, if we join a characters table with an adventures table using select characters.name, adventures.title from characters, join adventures on characters.adventureid equals adventures.id, we can intertwine data from both tables, crafting a richer and more diverse data story. In the end, by using join operations, we unlock a realm of possibilities by interconnecting data from multiple tables, which enables us to tell more complex and engaging data narratives. The insert statement in SQL is used to add new data into a table. The syntax follows this pattern. Insert into table name, column 1, column 2 values, value 1, value 2. Let's take an example. Insert into party roster, name, strength, attribute, values, Eldor, high wizardry, wisdom. Here we just added a new character called Eldor into the party roster table, specifying his strength as high wizardry and his attribute as wisdom. While using the insert command, remember to ensure data accuracy, understand your table's structure, and be prepared to handle any errors that might crop up. Mastering the insert statement is crucial for effective data management in SQL. Moving forward, we have two important SQL commands to discuss: update and delete. The update statement tweaks existing data in the database. For instance, update hero set level equals 10, where name equals Merlin. This modifies Merlin's level to 10, preserving data accuracy. On the other hand, the delete statement expunges specific data entries, like delete from game members, where last login 2023 EO1. Here, we're removing any game members inactive since 2023, ensuring database efficiency. The dynamic interplay of update and delete therein lies the versatility of SQL. With concepts of data modification and deletion under our belt, let's expand into intricate SQL operations. Today, we delve into database transactions and performance optimization in SQL. In essence, database transactions are a sequence of operations grouped as a single unit. Commands like commit seal data, whereas rollback reverses changes. An example sequence could be start transaction, update customers, set contact name equals 1, commit. This ritual ensures data integrity against anomalies. On to performance optimization, techniques like indexing, exemplified by create index IDX last name on customers, last name, map data efficiently. Crafty queries like select char from customers where country equals Mexico enable smart data navigation. Caching using cache select from tblsk name stores frequently used data for faster retrieval. Secure transactions constitute the lock safeguarding our data, while performance optimization forms the key fine-tuning our navigation to this treasured information. We've journeyed through the kingdom of data, where databases are our libraries teeming with tables, our books of knowledge. We collected essential SQL spells, select to summon data, join to weave tales, and begin transaction for foolproof magic. We optimized our quests by refining our search using indexed methods and tweaking our queries for maximum efficiency. Now, it's time to fortify your grasp on SQL. Test your skills with join, dabble in transactions for secure operations, and fine-tune your queries. Your toolkit in SQL is shaping up, empowering you to navigate, execute tasks, and search with precision in the kingdom of data.